Welcome, everyone, and thanks for listening. I'm confident that what we have for you today is a great discussion on an exciting topic. Processing and interpreting volumes of data is important for both business continuity and enhancing end user experiences. Enterprises are turning to AI, machine learning, and analytics to make the right inferences from that data. So here, I'm going to talk about how enterprises are challenged to get that important AI project into production while satisfying all the requirements for being deployed across multiple environments with security and manageability. Organizations around the world apply AI technologies to transform business in ways that will reinvent how firms win, serve, and retain customers. Businesses are under pressure to evolve quickly and optimize processes, maximize revenue streams, track trends, and develop new business models using digital technologies. AI has emerged as a core capability which every organization must leverage in order to be an industry player. It takes leadership, a knowledgeable workforce, and a mix of the right tools to see success, but an AI infrastructure is also required to expand and infuse that intelligence into practical use cases. AI has emerged as rapidly becoming instrumental in driving the insights that empower businesses in today's connected world. Organizations today need to find complex relationships in large amounts of data and predict things that either cut costs or create value. But before we can start reaping the benefits of AI, there are some obvious factors that organizations should consider along the journey. The first is strategy. In order for people, process, and technology to function seamlessly, an AI strategy must be clear, concise, and adaptable. Also, the right people with the right digital skills are critical to successfully leveraging AI technology to transform the business. Talent can make or break digital transformation objectives. It's no surprise that the firms of all sizes are facing a lack of both well-curated data to train AI systems and formalized processes to assess key business challenges. And finally, technology. On one hand, AI needs the utilization of other technology tools to execute its tasks efficiently. On the other hand, it requires employees to trust that technology. AI can drive the insights that empower businesses as long as we can overcome this technology barrier. So AI success requires a formalized investment strategy. The first step on the left is to understand how and where data is being captured and stored. For data analytics, we need to understand where the analysis will occur and how much data movement might be involved. Are these high-performance environments, edge, cloud, hybrid, on-prem? How will the data be used? To get to an end game where we have a production-grade AI project that generates iterative insights that feed into business decisions, it all starts with data science and with modeling. Predictive modeling that relies on machine learning or even deep learning will eventually lead to unexpected inferences that could have a major impact on the business and the services provided. This is practical AI that can be trusted and can positively affect everyday lives as well as the businesses. We also need to ensure the right skills are available that can leverage AI technology and eventually transform the business. Whether you need to develop these skills in-house or hire in some data scientists or get advice from outside consultants and suppliers, it's pretty likely that your workforce will need to adapt to handle this. The chart here shows a good list of skill sets that would be useful for AI, from the data analyst to the engineers to the data scientists. It includes everything from statistical programming to machine learning techniques to data visualization. A good list here. So the process to achieve a production model is key to eventually improving efficiencies in business and IT operations. AI is like an iceberg where everyone focuses on the visible top layer, the shiny application layer, but forgets what is under the water, the big part. And that is seen as an infrastructure problem. How to get data, how to clean and prepare the data, how to build models into production-ready artifacts, how to manage the workloads and scalability. The goal here is to eliminate the complexity of the AI infrastructure through a holistic approach that spans from services to infrastructure to support. The challenge is to get the AI project into production while satisfying all the requirements for being deployed across multiple environments with security and manageability. Data scientists need workflows that can be changed as the underlying hardware changes. And data scientists and AI operators need software building blocks and guidance on deployment, as well as how to manage those workloads remotely. So ultimately, it comes down to technology and the tools and packages that will be used to unlock the insights from the data analysis. An AI stack such as what is shown here provides a guidepost that businesses can use in developing the right environment and models for AI projects. There are many technology decisions to be made along the way. Starting at the bottom of the diagram, what hardware platforms or accelerators are available to you? Where will your analytics applications be deployed, monitored, and managed? Where will the data be collected and then analyzed? What additional infrastructure or container orchestration and management might be needed? For application orchestration, how will your pipelines and workflows be developed and validated? Also, what additional machine learning or perhaps neural network libraries and tools will be needed in developing AI containers? Once you have these building blocks and this end-to-end technology guidance, you can achieve an optimized infrastructure for your AI project that fits in your architectural environments. So in identifying what the real challenges are, we know that artificial intelligence platforms can be fairly complex. They combine a multitude of tools and frameworks that help data engineers to solve the problem of building end-to-end pipelines. But those AI platforms, by inheritance, have a degree of complexity. The end goal of every organization that utilizes machine learning is to have their data models successfully run in production and generate value to the business, right? But before a model ends up in production, there are potentially many ways or many steps required to build and deploy an ML type model. Data loading, verification, processing, feature engineering, model training and verification, hyperparameter tuning, and model serving. In addition, machine learning models can require more observation than traditional applications because your data inputs can drift over time. Manually rebuilding models and data sets is time consuming and could be very error prone as well. So let's look at first a typical use case and how we can address those complexities. And yeah, I need more coffee. So first, let's look at how AI projects have traditionally been handled, revealing the challenges in getting an AI ML project into production in a timely manner while meeting requirements. So let's meet Jen on the left-hand side. Jen is a data scientist. Jen knows math and leverages her understanding of mathematics, statistics, and simple programming to solve complex problems with a definite business goal. Also meet Sasha, AI ML operations. Sasha optimizes how pipelines run before deploying the applications to production. Jen wants results and writes a model in a notebook on her laptop. She wants to see the results of her code quickly and without administration overhead. She then converts the model into a pipeline compliant file. The pipeline code is only needed to run something that already exists in a different environment, basically. Jen then uploads the model to the AI platform for execution. Jen watches over the pipeline execution, iterating and fixing the pipeline over and over until it is successful before deploying it to production. So note in this whole process, running and fixing the pipeline towards success can take an unpredictable amount of time. And throughout that whole iteration, Sasha cannot be of much help, really. He cannot change the pipeline directly, and he has no idea what Jen is running on the infrastructure or when it runs or with which requirements. Resources are used without the operational control, essentially, and the whole process ends up being quite inefficient. Now let's look at an alternative. So we look at tomorrow's automation. And let's look at how we can use orchestration, collaboration, and automation to get the AI project into production environments on time and while meeting all the requirements it might have for security, control, and manageability. As before, Jin writes the machine learning model and refines it on her local laptop, but then she uploads her models to the Git repository automatically. This allows Jin to make her model available to others. An AI orchestrator enables Jin to share the model and optimizes it. Jin passes the ball over to Sasha. When Jin is happy with her model, she submits it to Sasha for preparation and scheduling on the AI platform. Sasha receives Jin's submission. He prepares the pipeline and workload based on Jin's requirements with an eye on optimization, changing parameters, Docker images, worker nodes as necessary. So Jin collaborates with Sasha to optimize the model. Sasha may change containers, define when the pipeline runs and on which environment. Once the pipeline is optimized, Sasha schedules it to run on their AI platform via the orchestrator, and the collaboration continues. Jin passing the ball doesn't mean taking her eyes off of it. Jin wants results accurate enough to fulfill business requirements as quickly as possible. Sasha wants to optimize the speed, load, and consumption of the cloud resources. Neither of them have to learn the details of the AI platform, but both can focus on what matters to them. And Sasha can now execute the pipeline on any configured target. So with orchestration of the machine learning models, collaboration and automation of the workflows and the pipelines, we can better achieve faster deployment to production while meeting requirements. And that's key. It's also important that as they are collaborating on optimizing the model, that the right frameworks, tools, and packages are readily available to them to ensure compatibility and portability across the multiple AI platforms. So here I show a few open source packages available cohesively to help Jin and Sasha develop and test the models prior to production. These packages enable you to jump from one configuration to another quickly and smoothly. So we want to approach AI application development and deployment using orchestration tools to help us assemble all the building blocks we might need. Eventually, we'll have containerized and high-performance AI that will be deployed across multiple environments. To get there smoothly, our data scientists use optimized templates to jumpstart the workflows and configuration. Pre-built workflow simplifies the project, and partner stacks help drive and guide the AI operator through the whole deployment experience. The end result is an accelerated project for machine learning with a tested and a manageable solution. An AI orchestrator is fundamentally a tool that removes the friction associated with creating, testing, and deploying machine learning models across multiple development, training, and execution platforms and frameworks. It relieves the data scientist of the burden of translating a data model into the execution steps of a particular AI pipeline or a workflow. An AI orchestrator also opens new avenues of collaboration between the data scientist and the AI operations team by enabling the appropriate platform. So in the end, this ensures that project costs remain predictable while slashing the often weeks-long delay in execution. So once we're able to orchestrate the development and the management of optimized machine learning models, data engineers are faced with the challenge of building infrastructure pipelines that are adaptable, available everywhere, and reproducible without constant reconfiguration. For example, a flexible AI infrastructure is needed as organizations evolve towards edge computing. Another innovative project that we have called K3 AI builds a microinfrastructure that removes the complexity of the installation, configuration, and execution of any AI platform so that the users can focus on things like predictive modeling and inferencing. That's what this K3 AI community project is all about, producing a reference architecture to help AI professionals, students, and researchers learn and grow while implementing a modular and a lightweight AI stack. So the resulting reference architecture is shown here on the right. It's a complete AI stack where all layers seamlessly operate together. This stack progresses from the server hardware to the accelerators to the orchestration layers and the frameworks needed for AI development and deployment. Throughout the development process, your data scientists will need easy access to packages important to AI. This helps establish the virtual machines configured to run the machine learning applications. Just a few of the AI packages are shown on the bottom left, including Kubeflow projects for building machine learning pipelines, TensorFlow for machine learning, Jupyter for building AI models, and more. So AI orchestration reduces project time to production through automated workflows that can be changed as hardware changes. It can provide a self-contained environment that has everything needed to develop, train, and push machine learning models to production. An AI stack, such as for AI infrastructure for edge, eases deployment and management of AI with software building blocks and guidance. This provides an optimized infrastructure that perfectly fits the customer's hardware architecture, which could be, for example, like edge devices with full capability of a Kubernetes cluster. And third, you can use a powerful platform and tools for managing and supporting data-intensive workloads across on-premise, cloud, and edge environments. And finally, if your data scientists and engineers are interested in getting more involved and learning more about some of these innovative open source projects that I just talked about, here are a few links to help get you started. Processing and interpreting volumes of data are important for both business continuity and enhancing end user experiences. Enterprises are turning to machine learning and analytics to help make the right inferences from that data. But organizations are also challenged to get that important AI project into production while satisfying all the requirements for being deployed across multiple environments. So with the right orchestration and the right guidance, we can achieve practical AI that helps us gain insights and shine a light on dark data and leads to decisions that can positively affect not only our businesses, but our everyday lives. So with that, I hope this information was both useful and interesting, and I thank you very much for listening.